Evaluating functions with an emphasis on quadratic functions. Okay, so here's a quadratic function, and we know it's a quadratic function because quadratic functions usually have this x squared. So this is a quadratic function. Now what we'd like to do is we'd like to evaluate this guy for various values of x. We'd like to put in different numbers for x, and then we'd like to see what we get for y. And the reason we want to do that is because we'd like to graph this guy. So let's take a look. Let's make a table. And when we make our table, we'll have an x and a y. This is also known as a t-table. And in this t-table, we're going to pick various values of x. Now the thing is, whenever we want to evaluate a quadratic function, we don't know that we want to start with 0 in the middle of our table. If we do a linear function, we might have a -1 and a -2, and we might have a 0 and a 1 and a 2. But with quadratic functions, we don't know that we're going to get the most interesting part of the function if we do that, because quadratic functions, they might be way the heck over here, or they could be way the heck over here. And if you recall, x equals 0 is here, and 1 is here, and 2 is here, -1, -2, wouldn't make a whole lot of sense to make our table look like this. So what we want to do is we want to find the middle of this quadratic, then we'll figure out our x values, and then we'll evaluate and get our y values. So there's this little trick that we can do when we want to find out where the center of our parabola is, and then that'll make it so we can pick better x values. So what we do is we say x equals -b over 2a. And that particular concept is known as the axis of symmetry. This setting x equal to -b over 2a, that is going to help us find the axis of symmetry. And the axis of symmetry for a parabola is just the line that goes down the center. So the axis of symmetry, this is not the world's best dashed line, but it's kind of a line that goes up and down the middle of the parabola, like such, and that's what we're looking for. We want to find that line. So if you'll recall, when we have a quadratic function in standard form, what we do is we say the number in front of the x squared, we call that a, and the number in front of the x, we call that b, and the number that's all by itself, we call that c. So in this case, our a is equal to -1. Remember, if we just have a negative sign out in front, then that's the same as having -1. Our b is equal to -2, and our c is equal to -3. Now, at this point, c being equal to -3, we don't care. All we need is b and a. So in this case, what we'll say is that x must equal -b. Notice b is already a -2. So what we're going to do is this. We're going to treat -b like like negative set of parentheses. And the same for 2 times a. A will treat like a set of parentheses. So for b, since it's -2, we'll go ahead and we'll plug in -2 into the set of parentheses. And for a, since it's -1, we'll plug in -1 into our set of parentheses. Now this should make it so that it's a little bit more straightforward what the sign will end up as when we're finished here. So let's take a look. So we'll go ahead and say x equals -2, that's going to be a +2, and that's all over 2 times -1, so that's -2. So ultimately, the line of our axis of symmetry, x equals -1. Okay, now again, remember, what that means is this. X equals -1 means that the middle of our parabola will be somewhere along this line. So what we need to do now is we need to find the y coordinate of, and when we do, that will be our vertex of our parabola. So let's go ahead and let's use this chart over here. So we're going to put x equals -1 up somewhere in the middle of the chart. I'm going to go ahead and put it right there. And then what I need to do is calculate the corresponding y value. So we'll begin to evaluate this function for the value -1. One way to evaluate this function is to go ahead and take this -1 and plug it in here for x, and then plug it in here for x. The problem is many students will then perform order of operations incorrectly. And you're going to give me a chance right now to determine whether you're one of those students or not. Go ahead and pause the video, and when you do, I'd like you to evaluate and find out what you think y is when you plug -1 in here and in here. Pause the video, take a moment, and when we come back, I'll show you how I did it. And let's compare answers. Okay, we're back. So the way I'm going to work this is like such. I'm going to say that I've got negative parentheses squared minus 2 times parentheses minus 3. And then I'm going to go ahead and plug into the parentheses my -1. So -1, -1. Now you can see that this has a whole mess of parentheses, and that's going to make it easy for anyone to make a mistake. So let's take a look and let's see what we got to do. We'll use PEMDAS, order of operations. The first thing we'll do is we're not going to take this negative sign and do anything with this negative sign. The first thing we're going to do is deal with this exponent, because that's what PEMDAS says to do. Exponents first, and parentheses. So this means when I see -1 with the squared here, it means -1 times -1. That's what -1 in parentheses squared means. So that equals +1. But I still have a negative sign out in front. Don't forget about that. So as a result, with that negative sign out in front, this becomes -1. So ultimately, all of this stuff here becomes -1. Let's evaluate the next part here. So now we've got -2 times -1, and so that gets us +2, and then finally -3. All right. Now, we can now then go ahead and simplify. -1 and -3 is -4 plus 2. That should get us -2. And I'm hopeful that's the answer that you came up with. But if you did not, well, then you need to practice. And we're going to practice this a few more times together. Now, once we've determined the vertex of our quadratic function, or our parabola, we can then pick x values on either side of our vertex. In other words, okay, we know that our vertex is at about, it's about right here. So what we're looking at, this is an x value, -1. So maybe we'll pick values like 0 and 1 and -2 and -3. Okay, -3, let's write this out so you can see it, -2, 0, 1. These are the x values that we'd like to try, because if we put dots down on the graph here and wherever they go here, we'll see what our graph looks like. So in the table, I'll go ahead and put -2 and -3, and then down here I'll put 0 and 1 and 2. And my main concern is the negative numbers, because those make it most difficult to evaluate a function. So let's go ahead and let's try plugging in these negative numbers into this function. Let's see how that works out. So -2, again, I'd like you to pause the video, and I'd like to see if you kind of got it from my first example. See if you can evaluate y. Go ahead and pause the video, and when we get back, I'll try to evaluate what y is. Okay, welcome back. Let's see here. So again, we'll start with negative parentheses squared minus 2 parentheses minus 3. And I'm going to go ahead and plug into the parentheses this negative 2. So negative 2 goes there, negative 2 goes there. And again, I have to do PEMDAS. I'll square this first. So this becomes, just so you guys can see, this will be negative 2 times negative 2. That's what negative 2 in parentheses squared means. And that gets us a positive 4. But remember, there's this negative sign out front. So that'll be a negative 4. For those of you that aren't quite sure that this is negative 2 times negative 2, another way we could write this is we can change from subtracting to adding the opposite. Hopefully you guys are with me that if I have 5 minus 2, that should be exactly the same as 5 plus a negative 2. This rule, what I'm doing here, I'm using something called the subtraction rule. Subtraction is exactly the same as adding the opposite. Here I'm subtracting a positive 2, and so I can change that into adding a negative 2, the opposite of a positive 2. Here I get 3, and here I also get 3, so it works. So let's see if we can use that here to help us understand why this is just negative 2 times negative 2. So I'm going to go ahead and change this to adding. And as a result, I'll have to add the opposite of positive 2, which is negative 2. And now hopefully you can see I am just going to add negative 2 times negative 2, which is going to be positive 4. And then again we do minus 3, and that gets us negative 7 plus 4 is negative 3. And I'll go ahead and I'll put that in here in our chart. And then we'll do this again. Okay, so I'm about to plug negative 3 in here and here, but before I do and get the result, I would like you to go ahead and try it on your own and calculate and see if you can get the y value. And go ahead and pause the video, and in a minute I'll show you what I think we should be doing. Okay, welcome back. So again, I'll write this out as negative parentheses squared minus 2 times parentheses minus 3. Now, I know it might seem like it takes a while to write all this, but if you keep doing it over and over and you get in the habit of doing it, you go faster. You kind of get into a zone. So don't be afraid to write all that if it's going to help you get the correct answer. Again, I'll go ahead and plug in the negative 3, and I'll plug in the negative 3 here as well. And now I can go ahead and I can evaluate this whole thing. Again, negative 3 times negative 3, remember the squared, gets me positive 9. And then I've got to put the negative sign in front. So that'll be a negative 9 after all is done here. And then again, plus a negative 2. So plus negative 2 times negative 3 gets me positive 6, and then minus 3. That'll be negative 12 plus 6 is negative 6. And so what I get right here is negative 6. So yay! Woohoo! We did it. Now, just for the heck of it, we'll try doing a positive number just to make sure you're totally with me on this. Okay, so let's go ahead and plug in positive 2. So again, please go ahead and pause the video and work ahead, see if you can plug in 2 and see if we get the same result. Welcome back. Let's see here. So I'm going to go ahead and say negative parentheses squared minus 2x, minus 2 parentheses minus 3. So we'll go ahead and we'll plug in that positive 2 here and here. And then let's go ahead and 2 squared is 4 with a negative sign in front. So that's negative 4. And then here I'm going to change this to plus a negative 2. So I'm going to add negative 2 times 2. That gets me negative 4. So I'm adding negative 4 plus negative 4, and then minus 3. So this is negative 8 minus 3 would be negative 11. So the result you should have gotten here is negative 11. And I hope that you agree. All right, if you want, you could go ahead and finish this off and do the graph. I'm going to go ahead, actually, since that's our vertex, if I did everything properly, this guy right here should turn out to be -3, and this guy right here should turn out to be -6. And I'm going to go ahead and put these points on the graph so you can see what the parabola looks like. So we already had a dot at our vertex at -1, -2. At -2, we have -3. So here's -1, 2, -3. So right here, we've got -3. And then at 0, we have a -3. So I'm going to put a dot right here. There we go. And then at -3, we have a -6. So we got to go down 4, 5, 6, something like that, and that goes all the way out here. And then at 1 we have a -6, so that goes all the way right down here. All right, and then I'll go ahead and I'll just connect those dots and we'll have our parabola. So yay, there's our parabola, and hopefully it matches up with our expectations. Hopefully you recall that if the number in front of the x squared, a, if that turns out to be negative, we'll have a frowny face parabola. Remember, frowny face. And this looks a bit like a frowny face. So yay, we did a pretty good job. Let's take a look at one more example. Okay, so let's pick up this party where we left off last. We're going to try another example. We'd like to evaluate this function and graph the parabola. I want you to pause the video for a moment and think about what is the first thing we're going to do. If you can remember it on your own, I'd like you to do it and try to calculate it. In a second here, I'm going to show you what it is that we need to do. All right, welcome back. Let's see here. So the first thing we need to do is we need to find the axis of symmetry. And the way that we do that is we find the vertical line that will have the equation x equals some number. And we can figure out that number by using the formula x equals -b over 2a. Now again, I'm hoping that you can remember how to find b and a. If you can't, I'm about to show you. So the number in front of the x squared is the a, and the number in front of the x is the b. So let's go ahead and plug those numbers in. So this will be negative parentheses, the b is a set of parentheses, 2 times parentheses, the a is also a set of parentheses, and we'll go ahead and plug those numbers in. So in this case, the b is -4, and the a is -3. And we'll go ahead and we'll try to evaluate that. Remember, -4 is +4, and 2 times -3 is -6. And we can simplify this to be -2/3. Now, if you didn't know it already, you'll notice that the negative sign's down below and I pulled it out in front. I just want to remind you guys that -2/3, you can get that by doing either -2/3, +3, or +2 over -3. All of these three things are equal to each other. Okay, so there's our axis of symmetry. So I'll go ahead and I'll put that somewhere around the center, -2/3. And then I'd like you to take a guess and see what numbers you're going to put in here for x. Pause the video for a minute, see if you can figure it out, and then I'll tell you. Okay, welcome back. If I've got a -2/3 here, you could go up 1 and down 1, like to, add 1 to this and subtract 1 from that, but that's a real hassle. Why don't we just do this? This is -2/3. 0 is over here, and -1 is over here. -2/3 is in between -1 and 0. There's no reason for me to choose fractional values for all my other values. And then over here I've got -2, and here I've got -3, and then down here I've got 0 and 1 and 2. Okay, so a few tricks that we had to figure out in order to evaluate this function properly. Now, instead of me walking you through the steps for evaluating this, because you're just going to be plugging this -3 in for x and the negative 3 in for x there, and you're going to do the same for negative 2 and the same for negative 1. You're just going to plug in all those values and evaluate and get y. You can use the technique that I showed you earlier, and to verify that you're getting the correct result, I'm going to show you how to use Desmos, the online graphing calculator. And with Desmos, it will show us what the values are. So why don't you pause the video and see if you can calculate y for negative 3 for x, and calculate y when x is negative 2, and calculate y when x is negative 1, and try one of the positive ones as well, and see what numbers you get. And then after you're done pausing, let's go ahead and take a look at Desmos together. Okay, so you go to desmos.com, and when you do, you get this graphing calculator. And over here we can type in our equation. I'm going to type in negative 3x to the power of 2, and then do minus 4x minus 3. And you can see this creates a parabola for us. Now, in order for now we know what the parabola looks like, and hopefully if you graphed it, yours looks like this. If not, you might want to graph it and see if it looks like this. In a second, I'm going to show you the table of values associated with this equation, and I'll actually show you how you can get it on your own for any equation. What you do is this: you click on this little gear that says Edit List, and when you click on it, it shows you the expression that you have typed in, and you click on the duplicate. And when you do, on the duplicate one, you go and click Convert to Table. And when you click on that, you will actually get a table of x values and their corresponding y values. Now, I already did that, so I'm going to get rid of that, and I'm going to go to the one that I created. And I put in a few extra negative values, negative 4 and negative 3 and negative 2 and negative 1. And right now they're not showing up on the graph. I can go ahead and make them display on the graph by clicking like this, and then you can see where the points are. Now you'll notice, because I did not include the fractional value, the negative 2/3, I don't have the vertex. I can see it there, but it was not being plotted from the table. That's okay though. For our purposes, my main concern is that when you are working with this function, I'd like you to be able to plug in these values, and I'd like you to be able to get the correct y values every single time. Now, I walked you through this. What I'd like you folks to do at home is I'd like you to redo both examples from scratch on your own without any help from me, without looking at your notes, and do that as many times as you need to until you can get it on your own without making any mistakes. If you can do that, then you can be confident that if you have to do it on a test, you will get the correct result. If you can't do it on your own without making any mistakes, when you're practicing, then it's going to be very difficult to get it right on the test. Good luck, folks.